So the first problem was to take our animation system and try to make it so that we could stay within the physical limits of the actual robot. And first thing we did is we took some shots from the film and we measured the accelerations. And what we found was there's one of the first shots we looked at, Wall-E lifted his head so rapidly that if we could make a physical system to do that, it would have become airborne, simply from the head rise. And so obviously we had to trim way, way, way back on what we could do with an actual physical system. And so I instrumented our animation system to show the animator the accelerations and velocities so that we could keep them within the limits of what the machine could do. But the bigger problem was that we wanted to combine pre-computed clips with puppeting, and that meant that the position, the configuration of the robot at the time when you wanted to initiate a motion would be fairly arbitrary. And so we had to figure out a way to transition into these motions from a position which may not have been anticipated. So for this, I worked very closely with animator Warren Trezevant. And Warren was quite adamant that he didn't want to have, and rightly so, we didn't want to have a home position that the motion had to pass through before you could enter in the pre-computed animated motion. And he wanted to make sure that the transitions had the same character as the rest of the motion. So we didn't want to have an algorithm to generate the transition that looked like it was just beginning and then the motion would start. So Warren and I developed something we called the empty pose technique. And the idea is that in order to animate, he has to create a transition from some position. What position is that? It's one that he selected almost arbitrarily. And from that position, as he authored it, he created transitions into the motion and then the main body of the motion itself. And the transitions for the different degrees of freedom, as you can see at the top here, they don't end at the same point. So there's certain bits of the absolute motion of the animation which start at different points in time. And what we decided to do was to take these authored transitions and the authored absolute motion and adjust them so that they could be started from any position that Wall-E could get himself into. And we did that by taking the transitions, scaling them appropriately in amplitude so they would match the initial situation, the initial configuration that Wall-E was in when the puppeteer hit that button to select the motion. We would scale that in amplitude and we would scale it in time. The temporal scaling depended on the acceleration and the velocity limits of the motors as they existed in the real Wall-E. So the result was a situation where you could begin these by any point in time and there wasn't a visible difference between the transition and the motion. And Warren was able, with this system, to specify whether certain things had a slow ease in and a rapid ease out, or vice versa, or overshoot, or anything else in the transitions. And he thought this was vital to creating the kind of performance that he wanted. So this shows the touch screen that we created for Wall-E, different sounds, different actions. And in addition to the touch screen, there was a 5-degree of freedom joystick, which we used to puppet the motion of either the left hand, the right hand, both hands simultaneously, or the head and the neck. And you could switch rather rapidly in between those. So here you see the puppeteer, Corey Rouse, operating Wall-E. In his right hand he has the 5-degree freedom joystick, in the left hand he has a more traditional joystick, which is used to control the driving. And then in front of him you can see the touch screen where he can begin any of the animated clips. And so here's Wall-E on the red carpet doing his tour of all the many countries that he visited in the course of promoting the film. So now I'm going to show you a brief clip from a Washington newscast. It's from the weather segment, and Wall-E is there in front of a green screen. So if we can make sure we have sound on this, that would be fabulous. And here we go.
Going to help me with the weather. Hi there. Absolutely adorable. We are so happy to have you here. And I hope you're happy to be here in Washington too, are you? You excited? I think Wall-E is very excited. Now, I want to make sure I'm pronouncing your name correctly because I've heard some people say Wall-E. I've heard some people say Wall-E. Can you pronounce your name for me? Wall-E. What do I have to do it that way? Wall-E. Wall-E. Well, don't be shy. You don't have to be shy. I think you're going to be very good at this because you have a good mind for science, and it's not going to be very hard. Can we put up, excuse me, let's put up the first graphic. Be a good robot, Wally. Let's put up the first graphic. It's we're going to show you. Yeah, you can take a look. The map is right behind you. There's the whole Earth. You recognize this, of course, right? You impressed? Yeah, it looks very special. Isn't it gorgeous? This is the United States, which I think you know. Can you tell me where it's raining? Very good. That's excellent. Wally is very good. Raining up in the Midwest, got some strong storms there. Let's go to temperatures. We're going to show you the temperatures right now all across the United States. Tell you what, tell me, this is going to be a little bit hard. Tell me, can you show me Los Angeles and show me what the temperature is there? I'll step out of your way just in case. That's right. That's right. That's right. Well, you don't know because you're standing right in front of it. It's 60 degrees right now in Los Angeles. Okay? That 60 degrees is fine. That's not too hot. Let's take a look at what the forecast is for the next 5 days. This is your 5-day forecast, Wally. What do you think of that? A lot of information there. It's going to be great today. It's going to be in the 80s all for the next several days until Tuesday, and maybe some rain on Saturday. Wally, you've been a great special guest. You did a very good job. I always ask our weather friends if they have any special talents. Do you have a special talent? Whoa, look at that. Look at I can't do that. I can't. Wally, ladies and gentlemen, has a big movie coming up in June. We'll talk more to Wally in just a little bit. Thank you very much. Wally. Now let's take a look at traffic with.
So I'm going to ask you to look at this or think about this a moment and ask, is it graphics? After all, he's not a computer graphics character in this. We're talking about a robot at the moment. And we use some graphics for the CAD. We use some graphics for the simulator. So you could validly say it doesn't really have that much to do with graphics at all. On the other hand, if he were a virtual character, you would do many of the same things. So I think if we're looking at whether we want to include this, we have to ask questions like, should graphics give it a home? Will it inspire good work? Will it keep the field vibrant? And I think these are some of the key questions as we go through as part of the technical program committee or reviewing submissions to SIGGRAPH and try to decide what we want to include. And finally, I want to discuss a particular issue, which is that the kinds of papers which are on the edge of the field, or the kinds of papers which introduce new topics, the kinds of papers which are provocative, are never in their first incarnation perfect. You can always look at them and find issues that you think are not adequately addressed because by their nature they stir things up. And so people haven't worked out, it's not really possible to have worked out every possible implication, dot every I and cross every T. And when these papers show up to SIGGRAPH, we look at them and we sometimes say, well, gee, you know, if this paper really doesn't work as well, or the method doesn't really work as well as maybe the authors are presenting it, if we include it in the conference, we might dilute the quality. But actually, I think that's a small risk, because if the paper is provocative, it takes a new idea, and eventually it turns out not to pan out, that will not actually reflect badly on SIGGRAPH, because it means that we have exciting new ideas, some of which lead to success and some of which are ultimately discarded. That's what you normally expect. But the other direction, I think, is where the risk is much greater, and that's the risk that we'll have a paper which really is interesting, which really could provoke a lot of new work, and we decide that, yeah, it doesn't fit in. We don't have really a place for it. And so we leave that out and instead try to make small incremental improvements on things that we've been doing. And this is what we have to avoid. We have to find, encourage, and accept these papers, bring them into the conference so that our field will continue to be vibrant. Because those are the papers that 20 years from now we're going to look at and we're going to say, yes, those are the reasons that we're giving out some of the next Computer Graphics Achievements Awards. So thank you very much.